Hi, my name is James DeLeon. I'm an undergraduate researcher for the University of Texas at Arlington, and I will talk about my work in the LArPix quality control work for the Deep Underground Neutrino Experiment. Neutrinos are fundamental particles naturally occurring in our universe. Um, However, they are electrically neutral and extremely hard to detect. Liquid argon time projection chambers have been a developing and effective method for detecting neutrinos. Furthermore, pixelated time projection chambers are a new technology that has been developed to uh, further enhance neutrino detection as a whole. The Deep Underground Neutrino Experiment, or DUNE, is an international organization um, designed to detect neutrinos and be a leading edge for neutrino physics around the world. With my work on the liquid argon pixelated time projection chambers, or our LArPix experiment, a series of quality control tests are performed to determine the overall electronic readout and response of each pixelated tile that is shipped to us. Getting more technical, a LArPix tile shipped to us is a 100 chip tile arranged in a 10 by 10 grid with pixelated sensors on the back of the tile. These pixelated sensors are driven by the 10 by 10 or 100 chip configuration. All in one network, these chips are driven by a controller. This particular controller is a pixel array controller and network card, also known as a Pac-Man controller. Before we start testing a pixelated LARPix tile for cosmic particles data, we have to properly calibrate the LARPix tile. And this is achieved through two methods known as a pedestal analysis and a leakage current analysis. The pedestal analysis is a diagnostic test on the LARPix tile that tests for channel noise. With each chip on the 10 by 10 tile, there are 64 channels. And these 64 channels may fluctuate in noise capacity. And to have it as little interference as possible, channel noise is forcefully triggered through the system. And channels that have a particularly high rate can be channeled out, voluntarily disabled, and the LARPix tile can move on in a calibrated state without having that much interference attached to it. On the other hand, for a leakage current analysis, leakage current within the tile is accumulated on the front end so that a specific threshold can be achieved. This threshold is in direct uh, proportionality to the self-triggering rate of the tile. A rate too high can introduce some interference into the LARPix pixelated tile and thus has to be voluntarily disabled. So overall, neutrinos are fundamental and they are extremely hard to detect. Um, this investigation into pixelated technology provides an opportunity for the neutrino physics community to enhance detection and analysis of neutrinos as they occur in our universe. What I plan to do for this project in the future is to streamline and automate a process in which a large number of tiles can be shipped to the University of Texas at Arlington. And this process for detecting interferences and disabling interferences for proper um, cosmic testing can be achieved. Also to provide an ample amount of documentation for these analysis methods so that other universities responsible for QC testing can follow along as we are analyzing these tiles. Thank you so much for listening.